There is a rectangular block. This word that means every face here should be rectangle and is provide lots of 90 degrees. And then they say CQ is 9, QH is 15 cm. We have to find the angle PFQ. PFQ and sine ratio of this. This is our target. So to do so, of course, we are interested in the triangle PFQ. We try our best to get as much as length here that we can. Maybe we look at PQ. We have one line, one right angle, and if we can get PC, that implies we can get PQ afterward, which means that I focus on this plane. And this plane is a right angle here. Now our target is to find PC. That's why I need to draw the base, the horizontal ground vertically to help us to find out PC. If I draw the plane, which is DCBA, P is the intercept of diagonal. We have 12 here, we have 16 here. So we know that the total length of AC is equal to 12 square plus 16 square divided square root, which is 3 to 4 to 5. So that's why this is 20. Which means that half of it is 10. Total length of diagonal is 20. We have 10 here. So by considering this triangle, 9 square plus 10 square square root is the length of PQ. We know PQ is equal to square root 181. Similar reason, we can also get FP and also FQ by using this method. For FP, we are looking at this triangle. Again, we have right angle. This length we already found is AP. And then F to A, which is the total height, 9 plus 15, we have 24. Then we can get the length of FP. If you realize that this is 5 to 12, then this one should be 13 times 2, which is 26. Or you may get it FP is equal to square root 24 square plus 10 square. Then you'll get 26 afterward. And then finally, we get the last length, which we need to draw a line connect F and H. The distance is 20 because it should be the same as AC here. 3 to 4 to 5, so this length should be 25. Remember, some common ratio is very important for MC to save some time. So now we have this angle and the corresponding triangle information. We just draw the triangle here. This is point F, our target, and then we have point P and Q. FP is 26, FQ is 25, and we have square root 181. We can't get sine theta directly, but we can get cosine theta. So we use cosine formula 181 square root square is equal to 26 square plus 25 square minus 2 times 26 times 25 cosine theta. We want to make theta be our target. So we change the subject. Cosine theta is equal to 26 square plus 25 square minus 181 divided by 2 times 26 times 25. We get 56 over 65. If we consider a right angle triangle with cosine theta 56 to 65, that means the adjacent side is 56. Then the hypotenuse is 65. In order to get sine theta, we want the opposite side. We can obtain it by Pythagoras theorem, 65 square minus 56 square. Then it is 33. So our final answer, sine this angle, is this opposite side divided by hypotenuse. It is 33 over 65. We get the answer A. You may think this question is quite complicated, but I think it's quite typical, easy, and also just applying Pythagoras theorem, something like that.